Concentrate on this. So if you have that out, look at it. This is what happens to a universe where the Q is greater than half. You see? The universe expands, expands. We live in the present right here. Okay, you see? We live 13 billion years. You see here? From here to here is 13 billion. Here. You see? 13.7 billion. We live here. So if we lived in this kind of a universe, the universe would continue to expand, reach a maximum size, recollapse. And then if it's oscillating, you would go like that. If Q is half, the universe would expand, 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 and then just continue to expand, kind of plateau out. If Q is greater than 0, less than half, so that's why it's good to see the visual, what this means. It goes with the notes. And then the universe expands, 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 but it slows down also, you see. This vertical line, this black one that you're seeing, is a universe that expands at a constant velocity, always, just constant. Okay, how about if Q is less than half? Actually, I should say here, I should have written Q is less than 0, actually, sorry. Change that if you have it in your paper. Change this to Q is less than 0. Not, it shouldn't say less than half. So as long as Q is negative, this is what's going to happen. The universe starts here, expands, slows down, accelerates. You see? So accelerates means it just keeps getting larger, larger, larger. So right now, we're actually starting we're living in the accelerating phase. You see here? Like that. Now, which of these models do we live in? Well, based on the fact that we've discovered dark energy, we live in this model. You see? Now, the other way to test this model is to predict how old the universe is. You see here? So go back in time, go back in time, and go back in time, and go back in time, and ask yourself, when did the Big Bang begin? You see? The most that it could have begun was the Hubble time, 13.7 billion years ago. So from here to here is 13.7. You see? If this model of the universe is correct, the universe began about let's see, this is 3 and about 2 or 4. So maybe the universe began about 5-6 billion years ago. You go out there, if you discover objects that are older than that, you can rule out that model of the universe. You see? And we have. According to this model, the universe began about 3, 5, 8, 1 or 2 more, 10 billion years ago, roughly. Okay? You go out there, you look for objects. If you find anything older than that, you can rule out that model. You see that? So that's another way of determining which one we live in. If you live in this one, 3, 5, 8, another 3, around 11, the universe is 11 billion years old. You see? If you go and you find an object 12 billion years old, you've ruled out that model. So that's exactly what we have done. We find objects as old as possible, and we've found objects that were 13.4 billion years old. Okay, so you see, we found objects that are about this old. Well, according to that, which model is that? That's the accelerating model. You see? So according to this, the universe began as far back as possible, as close to 13.7 billion years as possible. You see? So based on the age of the universe, based on our findings, we conclude that we live in an accelerating universe that is as close as possible to the Hubble time as possible. You see? So that takes us to the last page of the notes. The age of the universe. So now we know the fate of the universe is going to accelerate forever. How long ago was the Big Bang? So one way to check which of the above possible universes we live in is to date the universe and compare with the predicted ages of each model. How do we date the universe? Go and find different objects in the universe as old as you can. So according to the bounded or closed model, the age of the universe is less than 2/3 the Hubble time. Remember that the Hubble time was 13.7. Therefore, according to the first model, the universe is younger than 9.2 billion years old. So according to the closed model, which was the one that I showed you, went like this and back, right? The universe is about 8 billion years old. Well, we found objects that are older than that, so we've ruled that out. According to the marginally bounded model, the universe is 2/3 the Hubble time, which gives you about 9.2 billion years old. And again, we've ruled that out. According to the unbounded or open model, the age of the universe is greater than 2/3. The universe is roughly around 11 billion years old. And again, we've ruled that out, like I said earlier. Therefore, based on that aging process, we've concluded on this model also. So according to the accelerating model of the universe, the time of the universe is less than T Hubble, but greater than 2/3. So it's as close to the Hubble time as possible. Therefore, the universe is between 11 to 13.7 billion years old, and as close to 13.7 as possible. So most of the evidence reveals that the universe is closer to 13.7 billion years because we have actually found objects that are about 13.4 billion years old, okay? Remember, we can't find objects that are exactly 13.7 billion years because we can't see past the recombination time. The universe is opaque back then, okay? And with that, all this hard material, you can now go and digest it, okay? So study this stuff. Pretty intriguing, huh? If you still haven't decided what to do your report on, you might as well pick one of these topics if you're interested.